My name is Andrzej Wolski. I'm with RipeNCC. Ja jestem Polak, który wyrósł pobliż granic Československa. Taką ja mówię NHAP-u, no that didn't mean mówię tak, rozumiem. And mówię, it's not rozumiem. Okay, I'm not going to present as Paul. I'm not even going to try that. When you talk to me Czechoslovak, I actually understand it because as a kid I was watching all the Czech and Slovak TV, but speaking not really that much. Let's talk a little bit about security. Some of the colleagues before, they've talked already about a couple of tools that I'm going to be talking about. So most importantly, the IRR and the RPKI. I'm just going to put a little bit of kind of a background and history and what is happening actually in those both technologies. Paul told you in the morning a little bit about the RipeNCC. Let me kind of put an emphasis on the kind of the core operations that we do as a regional internet registry. So our main thing is the distribution of the numeric resources of the internet. And those consist of IP networks, both IPv6 and IPv4, and ASN numbers, right? So everything else that we do is in addition to this, right? This is the core of our operations. We have about 18,000 members called Local Internet and Registry, abbreviated as LIRs, and we serve them in 76 countries. So we have a plenty of organizations that we have to deal on everyday basis. If a member wants to have a resource, whatever is ASN or IP space, he comes to us. We register this fact based on his request, and we document this information in the RIPE database. The reason is why we document this information in the WHOIS database is first, you are sure, and everybody around you, that the resource that you've got is unique, right? And that's very important. You wouldn't be happy if you would get the same network as your colleague did. And the second of all, we show to everybody else that this is the current holder of those address space. So if they want to reach out, they can find the information in this WHOIS database. From there on, we leave those objects for you to interact with. So you create underneath so-called assignments, so whatever you distribute to customers, and you also show us and show to the world your routing intentions in the part of the database, in the meaning of the route object and the ASN. At the same time as the RipeNCC has been, and generally the routing regional internet registries have been kind of incepted, so this is the beginning of the 90s, we are also thinking about building a common protocol to exchange information between networks. It was kind of a part of this kind of a brutal growth of the networks. There wasn't even internet. It was actually many networks, including the ARPA network, but there were others, such as NSFnet. There was the network from NASA that they had to somehow exchange informations. Up till 1989, we had plenty of those protocols. Most of them were distance vector. We had already RIP. That was from '88. We have eBGP, which was from the beginning of the 80s. We had gateway-to-gateway protocols. We had Hello protocols from NSFnet and their DEC network, etc. So there was a lot of protocols, and they weren't interacting very well, if they interact at all. And in many situations, the exchange of routing information, it was basically a copy of a static route. Right? It was still possible back then to just copy it. You all seen this kind of a napkin protocol, right? BGP in principle is a very simple protocol. The idea is that I have a routing table, I have a colleague, I turn around, I tell my colleague the routing information that I have, right? So that's simple. My colleague turns around and tells that to everybody else, including me as well. So this is a big rumor network. all right? Where I tell something to my friend turns around and says that to somebody else, he then turns around and says, again, those informations to somebody else. So it's a true rumor mill. But as the fact came that they also said, he said the same informations to me, well, I have a loop, right? So how to solve that? Well, we solved that by slapping informations that he got this information from me, right? And I being recognized by an autonomous system number. So to every route that I'm telling to my friend, I'm slapping this ASN to know that this is me. And if I'm going to get something back with my ASN slapped, I discard it, I toss it away. It's a loop. It shouldn't be there, right? So the last thing that we need to solve is, what about if I have two colleagues and both of those colleagues will tell me information about the same network? Which should I choose? Well, we're slapping those informations about the ASNs, right? That the update transit through. So if we look at this, at those informations, they basically create a route, a destination, a vector. And we use this vector as to decide how we should route to this particular destination. So if I'm getting two, I'm choosing the one which has this route, which is the shortest, and we call it an AS path. And in principle, this is all that you have to know about BGP. That's it. Right? There's nothing more. We've made it quite complicated with time. There's many iterations of BGP. Currently, we're using a BGP version 4, which actually one of the biggest changes that it brought the variable length of the net mask, so we can choose whatever we want. Security wasn't part of this, this effort, because at this moment of time, if you were an operator, you were trustworthy. Right? That was it. So we didn't have to worry back then about the security, and it's not an overlook. We wanted to have an efficient protocol, and we have, because BGP actually multiplied by billions, and we have still a big routing table, global routing table, and it still performs in the same way as it performed at the beginning of the 90s. So good job, well done, we can all go home. But nowadays, we have 65,000 ASNs. Very often, you don't even know the people who you're peering with, right? You know them by ASN, maybe you know them by name, but in person, not really. Do you know their intentions? No. Do you know how trustworthy, in the meaning of technical capabilities, what kind of capabilities do they have? You have no idea. And in principle, the BGP updates, they are not traversing from the origin to the, let's say, a source. It's not like IP packet where you have end-to-end connectivity. Actually, what happens is, when you're sending an update message, every BGP speaker takes this update message, puts it apart, puts it in a structurized kind of way, makes sense out of it, puts it back as a BGP update, sends it to its peers. And this happens at every BGP speaker. It doesn't matter if it's external BGP or internal BGP, it's all the same. And as it's a rumor mill, it's a rumor network, if somebody tells a lie in this network, within some considerable time, you can't even figure it out who told this network the lie. So it's pretty bad. And in the end, that means that the accidents will happen and are happening. We kind of put them in two brackets. The first ones are just fat fingers, right? The numbers are very close at the keyboard. Sometimes you forget to put a certain number. Sometimes you have to make an announcement quickly. And you know, numbers are next to each other. And you wouldn't believe, but one of the most common misannouncement is a /2. Right, because there are plenty of more than 50% of the global routing table is a /24s. So if you're putting a /20, 21, 23, 24, and you forget the last digit, there's your announcement. So those are the typical. The other one are just policy violations. Those are the changes that has been made to a routing of particular network that weren't really the goal. right? The main kind of example that everybody heard about it is Pakistan Telecom versus YouTube, right? It wasn't really the goal of Pakistan Telecom to bring down YouTube globally, right? What they wanted to do is to bring down the YouTube in Pakistan, right? Because they didn't like the content of YouTube. But it leaked out to PCCW, which at this moment was just a backup, right? They were actually in a backup situation, and PCCW didn't set up any filters, anything like that. And you know, it leaked out instead of going to dev null. It actually leaked out outside, and YouTube was down for about 2 hours globally. And with time, those things are happening more and more often, and we started to see kind of malicious players, right? You know about this attack that happened in April 2018, so barely 2 months ago, right? When a group or a single person, hard to say, got to a routers of ENET, a network in US, and started to announce 5/24s of Amazon Route 53 DNS service, right? And point DNS servers to some shady DNS servers that were placed in some network in Russia, right? For 2 hours, it was noticed. The guys were able to reroute customers of MyEtherWallet.com to their portal, right, where they put the information how to log into MyEther channel, MyEther wallet, and in this way they were able to steal the informations, steal actually the coins from the owners. It wasn't. I mean, it's hard to say actually how much did they steal and how much is it worth, but the users actually of MyEther wallet did it to some degree to themselves, because one of the things that those guys didn't do, they didn't put a real valid SSL TLS certificate. So what happened is the user of MyEther wallet, when they went there, they actually saw, this is not the certificate that you want to see. Do you want to proceed? And most of them said, proceed. So this is what we see in 2018. The incentives of stealing a route are very high. You can drop down a network which you don't like to be online, or your competitor, just by making an announcement. But what about if you make an announcement of, you know, as we did for YouTube, for Amazon, for Google? Well, bad things happened, and even those organizations cannot do much. How many of you actually got their address space hijacked? All right, there's actually two hands, because in principle it looks like about 10% of ASNs in the last 20 years have been hijacked. So there's always somebody that is a victim. At this moment that it happened, what did you do? Yeah. Yeah, you've tried to call people, email people, try to do whatever you can. There is no BGP police. If something like that happens to you, all you can do is reach out to the upstream of particular network that is actually making that announcement, or just wait. Right? If big networks, it takes hours to reach out the other end. What about you? If you are a smaller, maybe not that known network that do not have such capabilities. So incidents are common. Internet Society put this document when they figured it out that in 2017 we had about 14,000 different incidents. About 10% of ASNs were affected, about 3K of ASNs. And about one and a half ASNs caused at least one incident. So that's a lot. Qaeda also, that's a kind of a group, a research group in US. They also have something which is called BGP Stream. It's also on Twitter at BGP Stream, when you can see incidents as they're coming in. And there's plenty of them. So is it all gone? There's not much we can do? Well, we knew about the kind of the problem since the very beginning, right? Together with the original ASN specification for BGP, immediately it was followed by recognition that, yeah, anybody can make any announcement, right? But at this point, it wasn't seen as a big issue. We were actually happy that it's working. So immediately after that, there was a call for actions to set up a so-called a routing registry. And RDB won this one, and they set up a routing registry where people actually every network puts their own policy. So, you know, what is the routing policy? Who you connect? What are you going to announce? What are your routing intentions? And we started to put those informations in those databases. Nowadays, RDB is still one of the biggest one. It's routing assets database. You can read it as this. You can read it also as a routing arbiter database. So you make some kind of routing decisions. We are to some degree, some kind of an anchor in the meaning of distribution of numeric resources. So we also started to participate in the internet routing registry. So basically, when you're looking at the RIPE database, whenever we distribute to your address space, you can also register your routing informations there. And the difference between RDB and the RIPE database is that in RIPE database, this data is authenticated by our system of maintainers. So basically, first we know who you are exactly because we have a contract, you are a member, and etc. And then we give you a right to create those information. So we know that actually you've created that. But RDB and other databases, and there is currently over 30 internet routing registry, they have a different ways of putting the informations there. And the trustworthiness of those internet routing registries is questionable, right? For example, to put information in the RDB, all you need to do is put some money up front and just pretty much register. And now you can put any information that you would like there, right? So it's causing a lot of havoc. And additionally, if you have multiple informations in the routing database, then you have really a problem to figuring out which one is the true. So you accept all, right? So how this system should look in principle, you have a number of those internet routing registry. You should fetch informations about the networks that are surrounding you. That should go through some kind of a toolset. There's this well-known IR toolset which can generate out of the routing registry a full router configuration. There's a cool kit in the block called BGPQ3. Many operators are using it. That basically gives you a prefix list that you can generate from the internet routing registry or any kind of homegrown scripts that just fills up your particular need. Our database has an API, so you can pretty much build everything. And this should go then further as a static router configuration, as a prefix list most of the time, to your router. So who does it nowadays? Well, we know that CZNIC does it, right? Nick CZ, sorry. Where's Jakub, the previous person that, yes, you do that, right? So if you want to connect to this exchange point, you have to have a record, you have to have a route object in our region in the RIPE database. So internet exchange points are doing that for a long time. Many providers are doing that, tier 3, tier 2. Unfortunately, tier 1 providers do not do that most of the times. The reason is very simple. They have a lot of customers on both sides of their interfaces. Now, how much prefixes can you put in a prefix list on a router? 500, 1,000, 60,000? For sure not 700,000. Right? So over 60,000 prefixes in a prefix list, your router will start slowly dying. Right? So you can't do kind of this, unfortunately, globally. Stub networks are using it just to filter out garbage. Right? So things that shouldn't be seen in the global routing table. When we're looking at the coverage, right, this is our service region. As you see, the coverage also covers quite a bit of Africa. Any ideas why is that? Yeah, legacy, exactly. This is basically at a certain point, we were also serving in this region, right? Before Afrinig was set up, we were actually one of the two organizations that were distributing resources in our in this region. But when we look at the accuracy of the data, and you see there is a plenty of data which is from outside of our region, those informations are not really that accurate. That is one of the reasons why our community decided to drop a information from outside of our system from the RIPE who is. So it's not possible anymore to to register those informations in the right database. I mean, there is a possibility of registering, but there's going to be information that are not authoritative. What about RDB? That should be the big global one. As you see, it's missing the big chunk of our region because our database were there pretty much at the same time, and we were as strong. But they cover the rest of the world. But when it comes to accuracy of this data, it's completely different, right? Again, we having this issue where, let's say, about 50% of the routes are accurate. So that's not good. So what we can do about it? Well, there's plenty of things that we can do about it, but as we've realized pretty quickly, we also had at this point already some technologies that can help us. In particular, a private public crypto, right? I have a public key. I can put it on the walls or every building that I'm in, and I'm keeping my private key secretly in my wallet. If you want to send me an encrypted message, you take my public key and you send me this message, obfuscated or actually encrypted. If I want to send you any information saying that this is really me, I sign it with my private key, right? Nobody else have it, so you're sure that this information comes to me. So how we can use that in the meaning of routing? Well, the problem is that there's plenty of people, plenty of keys. So how we make sense out of it? Well, you come with some kind of trust anchor, right? And this trust anchor will publish information about all the keys, right? So in an example of this bigger network, we can think about it as a public key infrastructure. And if we stick that to our routing, you can make a statement and you sign it with your private key saying this is my address space, and I will announce it from this ASN. Very similarly to internet routing registry. Without all the additional things about the routing policy. We act in this system as a trust anchor. We distribute the address space. We sign the information that we distributed that to you. Now, it's up to you to generate those, as we call it, route origin authorizations. So those the routing intentions, what you're going to be actually announcing. So we show members announcement, right? There's this kind of a nice page that you go. We show you what you announce. From this, you can pick up the routes that you want to certify it and let the machines handle it. So this is a protocol. This is a protocol that is able to fetch information directly to a router. So you don't have to kind of have a static list or anything like that. The router can take this information and digest it by itself. This system is in productions for nearly 10 years. There's all the other RARs that are participating in it. And we've seen that the main feature of the system that everybody wants to have is make it incredibly simple. So I will go a little bit over my time and show you a couple of things, if you don't mind. Our system is one page. You go to this page. If you have to first says that I want to participate, and you're going to see your BGP announcement. If you made any ROAS for it, it's going to show as a valid. If you're going to see something wrong, you can click on it. It will say you, hey, the ASN is wrong. All right, fix it, create new ROA. It will tell you that this is the change that's going to happen. You publish it, and everybody can take it. So how does it look in the RPKI? Well, our region maybe it's not so extensive as with IIR because it takes a lot of history. But when we come into accuracy of this data, it's incredibly high. It rarely goes over below 99%. After what happened with Amazon 2 months ago, actually they started to put the information about their network as a RAWs in the system as well, so they see the real need. As you see, the accuracy is incredibly high, also within your countries, right? So about 1/10 of the prefixes are covered, which takes, well, doesn't matter how much space, but this number is incredibly important. So how does it work? We have the repos that are publicly available. You can fetch them right now to your laptop. They go to something which is called validator. One of the things that your routers are not good at is crypto. And this crypto is heavy, because it should be heavy, because it should be unbreakable. So this generates something which we call a validated cache, all the good things. And that can go with the RTR protocol, API to router, to your router, and router has a full list of the good ones, right? And he can now start to make decisions. In particular, if the raw is invalid, drop it. So this is how simple it is. The validator is a piece of software. Our community asked us to build one, so we did one. It's based on Java. You can download it and run it on any Unix system, including Mac OS X. It gives you this view of the routing, and it allows you to not only view it, what it's there, but also allows you to make any changes. It's your network, it's your routing. If you think that something should be in this system, you can spoof it. If you see something that it shouldn't be there, you can delete it, right? So the validator is something that you run on your side and you make the decisions. So the validator currently is as version 2.2.4. You can just download it from our website. Currently, we're running tests for Validator 3. So if anybody is interested, jump on, let us know what you think about it. And we are not the only ones who have an implementation of the validator. There are others. And if you want to run that in production, I encourage you to run at least 2 different ones, because yes, programmers make mistakes. So it's good to have 2 values of informations. All right, that's it. I don't think I have a time for questions, actually.
That's right.
So if something you can catch me, I should have a badge. Thank you very much.
Thank you very much.